Okay, so first off, this is from Monday. Let's just review and practice how to make Pascal's triangle. Because again, there's multiple ways you can get these coefficients on the terms. You can do the triangle, which is kind of my preferred way. I like to just make it once and use it. Or you can do combinations on the calculator, which I'm going to show you that today too. So remember, your triangle, of course, kind of space it in the middle. You start with your triangle of ones. Now, this whole chapter, the theme is patterns, nothing but patterns. Remember, you always start each row with a 1 and you end the row with a 1. So it's how to get the middle numbers. So I'm going to slide over a row here, 1 I'm going to start with. To get the middle numbers, you add these together, 1 plus 1, end with a 1. Slide over a slot, we can do this all day, 1 plus 2, 2 plus 1, end with a 1. I'm going to keep going, 1 plus 3, 3 plus 3, 3 plus 1, end with a 1. So I'm just kind of scanning ahead in our notes. I see our next problem is to the 6th power, so I probably do need some more rows here. So I'm going to add a couple more, 1 plus 4, 4 plus 6, 6 plus 4, 4 plus 1, end with a 1. All right, might as well do one more while I'm in it here. 1 plus 5, 5 plus 10, 10 plus 10, 10 plus 5, 5 plus 1, got it. So if you look, and this is really more of a review for those that were gone on Monday, if you look through in your notes, you can see there's this giant Pascal's triangle in there. Clearly, I made it through this row here, then I kind of ran out of room. Obviously, this is just a continuation on, so you have that as a reference. But you won't be provided that on a quiz or a test. You'll have to know how to make the triangle if you're using it. There will be space on it if that's how you want to do it. Now remember what these represent. These are the coefficients for your terms. Remember at the top is for the 0 power. Anything to the 0 power is a 1, okay? These are the coefficients if your power is a 1. So to the first, this is for the second, your third, fourth, fifth, and sixth. So that's why I wanted to get to the 6th power, because if you look at the problem right underneath it, 2x minus 5 to the 6th power, I need this bottom row. So that's why I wanted to add one more row so I had those numbers in front of me. So for those that were gone Monday, this is really for them. So of course I'm not writing this out 6 times and doing a truckload of distributing and taking half a sheet of paper. If I write small enough, which probably won't happen, you can do it in 2 lines. 1 line to set it up, 1 line then for your final answer. So 6th power, so that's why I added this bottom row. So these are going to be the coefficients on the terms. So I'm just going to jot that 1, 6, 15, 20, etc. down so it's in front of me. 15, 20. Okay, you've got it there on your triangle. You don't have to rewrite it, but so they're in front of us. Now notice, there's 1, 2, 3, 4, 5, 6, 7 of these red numbers, which means there will be 7 terms in my final answer. Patterns. It's always 1 more than the power. So if your power is 10, which that'd be pretty mean and awful, you should have 11 terms in your answer. It's always 1 more. Okay, to get the terms, first coefficient, 1. Start with that. I'm going to try to write small. I know I'm not going to fit it in a line. It just probably won't happen. First term of the binomial is 2x. That starts at the exponent. So starts at the 6th power. Your second term, take the sign, -5, starts at 0. Now, I can't say as I would really normally if I'm doing the homework write that, because anything to the 0 power is 1. We don't need it. But I'm just putting it on for the pattern. Okay, to get my next term, 6. 2x moves down in power, so it's down to the 5th. And -5 goes up in power. So now it's at the 1st. Your exponents should always total to 6, the expansion exponent. Okay, third term, 15 for a coefficient. 2x is down to the 4th. -5 moves up to squared. Good. All right, next term. I'm on 20 for a coefficient. You're probably going faster than me because I'm trying to color code it. 2x, that's a 2x, a sloppy 2x, is down to the 3rd. -5 is up to the 3rd. I'm going to fit one more and then I'm probably going to have to sneak at the rest underneath. Okay, I'm on 15. 2x is down to a squared. And -5 up to the 4th. Definitely going to need a calculator for these. We're going to get some big terms. Okay, I'm going to go underneath here. I'm running out of room. All right, I got 2 left to go, 6 and 1. So I'm on 6. 2x is down to the 1st. -5 will be up at the 5th. All right, final term. And again, if I was technically doing this, I probably wouldn't write 2x to the 0. I mean, that's not really helpful. That's just a 1, but I'm going to put it for the pattern, -5 to the 6. So if you write small enough, you might have that all in one line. Clearly, I failed at writing small enough to do that. Now, all I have to do is calculate these out and get my final answer. So my first term, of course, I don't care about the 1, -5 is 0, 1, who cares? I'm worried on this. So in your calculator, what's 2 to the 6? 64. So I'm going to have 64x to the 6 for my first term. Now, normally, again, I just do these, but this is more for those that were gone on Monday. Second term, you're going to have to, in your calculator, do 6 times 2 to the 5th. And then, of course, -5 to the first is just -5. So you're going to do 6 times 2 to the 5th times -5. Big number. What do you got? Yep. And I'm going to have x to the 5th. I'm going to move this up just a little bit. We don't need the original problem here. Okay, third term. In my calculator, I'm going to do 15 times 2 to the 4th. Okay, I just know -5 squared, 25. Let's just make it easy. So 15 times 2 to the 4th times 25, big number, 6,000. And one thing to point out too here, just as a little reminder, notice the terms are alternating positive, negative, positive, negative. That will always happen when you have subtraction in your expansion sign, 2x minus 5. If that was +5, they'd all be plus. All right, 20 times 2 cubed times -5 cubed. Make sure you put -5 there in parentheses. What is that? It's big. Negative 20,000. Okay, 15 times 2 squared, -5 to the 4th. Make sure you put -5 in parentheses so you have 4 negatives there. Or we just know it's going to be a plus. What's 15 times 2 squared times -4 to the -5 to the 4th? Big. What do you got? Daddy? Oh, sorry, 6. I was writing and talking. Sorry, thanks, Addie. All right, what do you have for this coefficient? Positive or negative? Positive. X squared, because you're going to have 4 negatives there. Okay, I'm running out of room, obviously. I'm going to do the other 2 underneath here. Okay, 6, 2 to the first 2, we know it. -5 to the 5th. You have 5 negatives. I know it's going to be negative. What's 6 times 2 times -5 to the 5th? Negative. Don't let it scare you. It's 37,500 again. Sometimes that happens. Okay, don't let that scare you, like I said. And x to the first, I'm just going to put x, of course. Okay, final term. 1, whatevs. 2 to the x, 0 to 1, who cares? Okay, we really need to know what's -5 to the 6. 6 negatives, I know it's going to be positive. Yeah, 15, whew, big numbers. But again, is it a little time consuming? Sure. A lot of calculations? Yeah. But that's way less work than if I were to write out 2x minus 5 6 times and start distributing. And distributing all of that and foiling the first 2 and distribute. It'd take me half a sheet of paper to do all of that. Now, the other thing I'm going to show you too, this is really more for those that were gone, okay? And I'm going to use it some today too. If you hate that triangle, you're like, man, I hate making the triangle. I just don't like it. I hate it. I don't want to do it. You can get these numbers off your calculator through combinations. And I'm going to show you where that's at too here in a second. So your exponent, of course, 6. So that's C60, 61, 62. You get the pattern here, 63, 64, 65, and 66. So if you look in your calculator under your math menu, we're going to use this again tomorrow too, go to probability over there, and you can see it's number 3. So if I want to do combination, I don't know, 6, 4, whatever, there's where the 15 comes from, right there. So I just personally don't like having to type in all the combinations. I rather make the triangle and just use it, but that is me. You can do it either way. It doesn't matter whatsoever. I might even, because I was like, 6 isn't bad. I mean, we just did it. 9, I don't know if I'd want to make a triangle out to the 9th power. I really don't know, especially if you're not provided one, you had to make it. I might do this with combinations. 8's even kind of big. I might do that with combinations, not the triangle, but I'm going to set them up both ways. Now, I actually kind of like today a little bit better because you don't have to do the full expansion. You would have to figure out one single term. That's it. So it's actually a little easier today. Okay, so 6 power. So if I'm doing it off the triangle, I mean, we just did a 6 power. We've got the coefficients there. You can see we got them here on our triangle. I'm just going to jot those down really quick so they're in front of us. So the 1, 6, 15, the 20, the 15, 6, 1. So you could get that, of course, from your triangle. You find the right row, you got it. Now, we want the 4th term, so I'm just going to count 4 in. 1, 2, 3, 4. So I know my coefficient I'm going to use is the 20. Now, it's the same setup as we've been doing, but we don't have to do all the work. We need a specific term. So now, of course, I'm going to count where x would be for an exponent, because, of course, this would be to the 6. I mean, I wouldn't write these. I normally just count it down. 5, 4, 3. Got it. And then, of course, my second term, negative 3. Now, I'm not going to count that one. I'm going to work smart here. These exponents should total to 6. So I know it's got to be a 3. Okay. So then I'm just going to punch in my calculator. Let's get our final answer. What's 20 times negative 3 cubed? Punch that in. 20 times negative 3 cubed. Negative 540 x cubed. Yeah. Okay. So you only need that one specific term. You don't have to do the full expansion. Now, if you're doing combinations, which is totally fine, okay? If I'm going to do the combination, pretend you don't have the 1, 6, 15, you don't have the triangle up here. So again, your first subscript is going to be your exponent. To get the second one, so you're doing the 4th term, it's always 1 less than that. So 4 minus 1, 3. Same deal, you're going to have to fill in your x, your negative 3, and you have to figure out the powers on these guys. Easy, easy peasy. This is just the pattern how it works. The second subscript always matches the second exponent. So I just copy it on there, okay? And then, of course, these have to add to our expansion exponent of 6. If you type that in your calculator, you get the exact same thing, okay? That's how you want to do it. And again, this 3, it's always 1 less than the term you have to find. So 4th term, took 1 off, 3. That's how I got it. So the next one, I'm going to flip it. I'm going to do it off combinations first. Because let's say I'm on the test and I was like, dang, I don't want to make a triangle out to, I need 10 rows. I don't want to do 10 rows. I don't have room for 10 rows. I'm going to go combination. So I'm going to set it up. My expansion exponent 9. Now 8th term. So I'm going to take 1 off of that. That's where the 7 comes from. First term, let's jot that down. We have 4x. I'm going to figure out its exponent in a second. My second term, 3y. Now, I know the exponent on the 3y because the second subscript is the second exponent. Easy enough. Now, get your, of course, your other one. Just a little mental math. These have to total to 9. So I need a 2. So it's kind of a little bit of a puzzle. It is a little bit more to like keep track of and memorize, okay? So of course you're going to punch this into your calculator. So punch in C97. I would do it all in one step, to be honest. I would do this times 4 squared times 3 to the 7. I would just punch that in my calculator in one fell swoop to get the coefficient, and you get a very big number. Give me a second to punch it in. Yeah. Let's throw the commas in here for you. And don't forget your variables. X to the what? We're lively today. Second, y to the 7. So personally, you know, if I don't have a triangle provided to me, that's how I would have done it, because I don't want to make a 10-row triangle. But you do have in here, in your very lovely note packet, let me scroll back here, you do have this big triangle. So, I mean, you, of course, could count 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. We can see, of course, you're getting down here to the row, and you could get it off of that. You can count in and get your coefficient that way. Personally, a big exponent, I do it with a combination. So that's what I'm going to do on this guy too. So again, combination. Our expansion exponent 8. You need the sixth term, so I'm going to take one off. That's how you get your second little subscript here. I'm going to set these up A, 2B. All right, exponent on 2B is super easy. The second subscript is the second exponent. We're going to do a little mental math here. What's your power on A? 3, because we got a total of 8. And again, you don't have to write this. I would punch this all in my calculator in one step. We need 2 to the 5th. And that will give you the coefficient. So what do you got for a coefficient? Got it. And I'm going to have a cubed b to the 5th. So again, I'm just going to show you 2 if you wanted to do this off the triangle. So 2 to the 8th power. So back to your triangle, just count it down. 0, 1, 2, 3, 4, 5, 6, 7, 8. So I'm looking at this row here, okay? It asks you for the 6th term. So I'm going to count 6 in. So 56. And guess what, kids? If you type in combination 8, 5, it's 56. And then you can, of course, figure out your variables from there. So I don't care if you do it combinations or you're counting on the triangle. Just be aware, come test time, you don't get a triangle provided to you. I can't say as I want to make one out to 10 rows, 11 rows, something ridiculous. I probably wouldn't. I would probably do it combinations. Hey, let's review for the final. You know, I love to review for the final. Okay, here we go. Let's do a couple of these. What is the longer side of a rectangular plot of land whose perimeter is 40, area is 96? Okay, all right. Let's draw a rectangle. You can use whatever, X, Y. I'm just going to do length and width. Nothing fancy here. Let's start with perimeter. It's like geometry class. How do you find perimeter in any figure? Add up all the sides. So I'm going to do L plus L. I'm just going to put 2L. W plus W. Let's just combine it. And it tells us the perimeter is 40. Got it. Okay, area. How do you do area of a rectangle? Length times width. And it tells us it equals 96. So good review. We are back to chapter 7, systems of equations. I'm going to use substitution or elimination. I'm probably going to use substitution because of this product in the blue equation. It's going to be hard to eliminate anything. So I'm going to solve this top green one for L or W. You pick whatever, and we'll substitute it into the bottom. So the green one, let's work on that. First, I'm just going to cut everything by 2. Let's just reduce it. And, you know, I'm just going to solve for L. I'm going to subtract W off. You can solve for either. I'm going to take that expression for L, substitute it in. So I'm going to replace that with a negative W plus 20. We still have times W, and equals 96. All right, let's just do the algebra. We're going to distribute. See what we got here. We're going to have quadratic. That's nice. 20W, 96. All right, now quadratics, we know lots of ways to solve quadratics. I'm going to go factoring. I'm going to pray at factors. Before I get to that, let's subtract 96 over. So we're set equal to 0. Now, you don't have to divide by -1 to switch the signs. Just, I always, that negative there, I always see a lot of sign errors that happen. So I'm just going to switch all the signs quick and make your life simple. Try to anyway. All right, let's see how good we know our times tables. What two numbers multiply to 96 and add to -20? 8 and 12. Good, I heard it. Positives or negatives? Negatives. Okay, there we go. W minus 8, W minus 12. You got your answers for W. 8 and 12. I'll label them at the end. Okay, we of course need the lengths. All right, let's take a look at the lengths here. Now, if you put 8 in here, so -8 plus 20. Okay, fine. You put 12 in there. -12 plus 20. Okay, is it weird that they're really the same answers? No, it's just a matter of, is your rectangle longer, 12 this way and 8 high, or is the 12 this way? So that's all it is. Now remember, your final exam is multiple choice, right? So you clearly, and the answers are just looking for the 12 and 8. I'm going to label, what are we in, miles? So 12 miles, I'm going to say by 8 miles. However, you want to arrange the rectangle. Just look for the 12 and 8. All right, well, let's do one more little practice problem. Throw back to chapter 7, systems of equations. Group of 70 people attends the ball game. There were 3 times as many children as adults. That sounds scary. Set up a system of equations that represents the number of adults and children. Solve the system to find the number of children that were in the group. Okay, so I'm going to write a system, of course. So 70 people. So however many adults plus however many kids, 70. You can use X and Y. I'm just doing A and C. Okay. There were, this is the scary part of this, 3 times as many children as adults. Okay, so to get the children, that's triple the adults. So if there's 20 adults there, there's 60 kids. Oh, gosh, okay. I'm probably going to use substitution on this. Let's throw 3A in here for C. Some of you can just mentally combine that in your head, but you know I love to show work, so I'm going to put A plus 3A, then of course equals 70. We got 4A equals 70. That doesn't divide out evenly. Punch it in. What do you got? Yeah. Now, again, multiple choice, your final, you don't want to pick that answer because it's asking you solve the number of children. Okay, so I want to know how many kids went. So what's 3 times 17.5? Now, we're talking kids. Sometimes I'd like to have, maybe 0.5 of some kids. I don't know. Does it seem weird to have 0.5 of a kid? Yeah, so let's round it. You want to round down or up? Let's go. It's kids. I round down just because it's kids. But we can round it up to 53, sure. 53 children. Ooh. Sounds like a lot of germs. Got it. All right, any questions on that? Okay, so your homework today, this is really pitiful. Mr. Potato Head worksheet. Get yourself excited, kids. So it's all of, I didn't even put any review stuff on. It's all of this stuff, the specific term. It's even multiple choice, guys, but I do need a little bit of work. I don't need a lot of work because it's multiple choice. I at least need to see like this, your setup. So at least write, that's all you gotta write down. And then of course, obviously punch it in your calculator and pick out the correct answer.